Now that we can see how repetition can be used and how flowcharts can be used to describe algorithms or repetition, let's see how we can use a flowchart to describe an algorithm for a simple processing program. Let's imagine that we wanted to calculate the sum of the numbers from 1 through to 5. This flowchart describes this process where we start with our first number and then add the next number in our sequence until we have calculated our sum. In this flowchart, we need to add a variable that will hold the value of our summation. We can call this variable sum. We start by initializing sum to have the value 0 and then proceed to add the value of our first number, 1, to that variable. We still have numbers to add, so we go back to that point in flowchart and add the next number, in this case 2. We continue this process until we have added all of the numbers in our sequence from 1 to 5. What if we wanted to modify our flowchart so it added all of the numbers in the sequence 1 through to 10? What would we have to change? In this case, we could change our condition so that it kept repeating our loop in the flowchart until we have added 10. What if we wanted to add all the numbers in a sequence 5 through to 20? What would we have to change then? In this case, we would change the value of the first number that we add, as well as the value used in the condition. So let's have a look now at how you could do this in processing. If we wanted to write this summation code, we could write it like this without using repetition. This would work, but just think about how tedious it would be if we wanted to modify our program, just as we have modified our flowchart. Using repetition in our programs makes it much easier to code and also to modify later if we want to. Let's now have a look at what this would look like if we use repetition in processing to implement this. What we have here is a for loop statement, which enables us to repeat a pattern in our program a number of times. A for loop is a programming statement that wraps a set of instructions up so that they can form a pattern that is repeated. To write a for loop, you need to understand the pattern that needs to be implemented, as well as the expression that will be evaluated to see whether the pattern should be repeated. In this case, the pattern that we want to repeat is the addition of the next number in our sequence. A for loop uses a variable which is initialized in the first line of the for loop definition to keep track of how many times we want to repeat that pattern. That variable's value can also be used within the for loop as a value for our expressions. This enables us to repeat a pattern that has required a value to be changed each time the repetition or loop executes. A for loop consists of the following template. The point of the initialization, test and update is to effectively keep count of how many times we need to execute the instructions contained in the loop. The initialization section is where we can declare a variable that holds an initial value. In this case, we have declared a variable called nextNumber, which holds the value of the next number in our sequence that is to be added to the sum. The test is where we write the expression that tells us whether we need to repeat the instructions. In this case, it is whether we have added all of the numbers in our sequence, or more precisely, whether the next number in the sequence to be added is less than 6. If it is, then we repeat the instructions. But if it isn't, we go to the instructions that follow our for loop structure. The last part, the update, changes the value of the variable declared in the initialization, so it is now the next number in our sequence. This gets the variable ready for the next repetition of the instructions in our for loop, which in this case are the instructions to add the value of the next number to sum. Let's have a look at what happens when we execute this code. Let's think about the changes we explored earlier in changing our flowchart. What if we wanted to change the number sequence to 1 through to 10? We could change the value 6 to 11 in our condition like so. Or we could also introduce a variable that holds this value. This would be useful in case we wanted to include multiple for loops in our program with the same repetition conditions. And if we wanted to modify our sequence to be from 5 through to 20, we could do this way. Or again, introducing a variable to represent the start of our number sequence.